In this lesson, we will see how indices are used in maths, and we'll have a look at the index laws. We saw that index notation is a shorthand way of writing repeated multiplication. The index laws help us simplify our numbers, so with the same base there we can add the indices when we're multiplying, we subtract the indices when we're dividing, and when we raise to a power and then to a power again, we multiply those indices. A zero index gives us 1, and a negative index means 1 over. And a fractional power means the qth root. We saw that 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. Our indices there are going up by 1, and on the right hand side we're doubling. So what does 2 to the power of a half equal? Well, 2 to the power of half would slot in halfway between 2 to the 0 and 2 to the 1. So we need to find some number that we multiply 1 by twice to get to 2. And that number, of course, is the square root of 2. So 2 to the half will equal the square root of 2. Another way of looking at it is to use the index laws. 2 to the power of a half times 2 to the power of a half. We add the indices there to get 2 to the power of 1. So we're looking for a number that multiplies by itself that gives us 2. And by the definition of the square root, that number is the square root of 2. So 2 to the power of a half is the square root of 2. So let's extend this now and look at 2 to the power of 1/3. When we multiply that by itself 3 times, we'll get 2 to the power of 1. And so we're again looking for a number multiplied by itself 3 times this time to give us 2. And so that number is the cube root of 2, because that's the definition of the cube root. We can generalize this and say if we have some number raised to a fractional power, then that's equal to the qth root of a. So for example, 5 to the power of a quarter is the 4th root of 5. We can have a fractional power with a numerator and the denominator. So a to the power of p over q is our fractional power there, is the qth root of a to the power of p. So for example, 7 to the 2/5 is equal to the 5th root of 7 squared. We'll use our index laws to simplify this expression. Because it's all raised to the power of 1/3 there inside the brackets, each of the terms have to be raised to the power of 1/3. That means that we multiply the powers that are already there by 1/3. So it's 6 times 1/3 and y to the power of 9 times 1/3. Similarly, each of the terms in the denominator are raised to the power of 1/2. So we will get 16 to the half, x to the 4 times the half, multiplying those powers, and y squared to the power of a half. So now we start evaluating these. The power of 1/3 really means the cube root of 8, so that will give us 2. Multiplying these powers together, of course, we'll get x squared, and then our y to the power of 9 times 1/3 is y to the power of 3, and so on and so forth. So our 16 to the power of a half is the square root of 16. That's 4. We'll get x squared, and we'll get y to the power of 1. And of course we can simplify this further. 2 into 4 goes 2, and our x squared terms will cancel out, and we'll have y to the power of 3 minus 1, which will give us y to the power of 2. We saw that index notation is a shorthand way of writing repeated multiplication. The index laws help us simplify our numbers, so with the same base there we can add the indices when we're multiplying, we subtract the indices when we're dividing, And when we raise to a power and then to a power again, we multiply those indices. A 0 index gives us 1, and a negative index means 1 over. And a fractional power means the qth root.